All right, welcome everybody for this live stream on a different setting on a different day than I am used to going on my channel. But I just wanted to kind of mix things up. To this week was kind of a little busy week here in the teaching world, so I was like, well, you know what? I'm just going to live stream from home, and today just kind of worked out to be a certain time. So hopefully that kind of works out for you. Otherwise, you might be checking, this live stream on the replay. So basically, what I need to do for this live stream is cover our homework for angles in trigonometry. And basically what we're going to do is just work on like sketching angles in standard form, as well as dealing angles that are in radian degree as well as degree form. And then what we discussed in our class, this last class period, was covering how to determine the reference angle as well as how to determine coterminal angles. So we're going to kind of work through that, quite a bit of examples just to kind of practice, because it is something that is going to be very important, especially for the next couple lessons that we're going to cover in trigonometry. And then what I'll do is just kind of take a break for anybody that's joined in. So hey, join, and hey, Junkwaka, Hungkoka. Something around there. I apologize for the badgering there, but I try to do my best as far as every single time I get students with their names, in school. It's always like the most embarrassing thing, because that's like one thing that I struggled with, as well as like pronunciation and stuff like that. So I apologize. Try to do my best here. But hey, Fazan, how are you? And glad you could join for the stream. So what I'll do is, if you guys have any questions, anything that I'm covering on this stream or just in general class, I'll be more than happy to take some questions here kind of at the break before we get over to the multiple choice. And then at the end, depending if I haven't really, we still have some time left here. We're starting at 2 o'clock. So, we'll look into roughly around like 30 minutes for the stream. And, if I have a little bit more time, if you guys have any questions, I'll be more than happy to answer them. So, and then, hey, Ozzy, how are you? So let's go ahead and get started in this and kind of work on our graphing trigonometric functions. And again, guys, remember this is something that I've already taught, so I'm not going to get into detail of explaining things. I will kind of, explain my steps and explain what I'm doing, but I'm not going to get into the very basics of one, because this is something this is a homework assignment. We've already covered the basics in my class, so we're just going to kind of review a lot of this stuff. So the main thing here in the standard form for our first angle, which is 3 pi over 4. And so just to kind of sketch it, what we're going to do is draw the standard form. Remember that standard form has our initial angle here along the positive version of the x-axis, has a vertex at the origin, and then remember positive is rotating counterclockwise. So this is that 3 pi over 4. Sometimes we like to use the kind of circle to understand that would be represented as pi, right? So we talked about where pi comes from. It's basically going to be, the rotation of rays halfway around. That would make half of a circle. And since we're dealing with force, we can rewrite this as 4 pi over 4. That means we can break this half circle up into 4 parts. And then what we notice here is if I wanted to graph 3 pi over 4, starting at my initial side here, I'd have to rotate 1 pi over 4, 2 pi over 4, 3 pi over 4. So this would be called my initial side, and then this would be called my terminal side. Okay, and again, just remember that direction matters when we're dealing with standard form, so you can see how I kind of drew this arrow showing my direction for this angle. Now, the next thing is let's go ahead and convert this to radians. So remember our conversion ratio was going to be, to convert from radians to degrees is just equal to 180 over pi. And again, the reason why we want to do that is because then the pi's are going to divide out, and then I just basically need to multiply or divide 4 into 180, and you can say that 4 goes into 180, that would be 45 times, so that's basically equal to 3 times 45, which looks like 135 degrees. Okay, and that makes sense, right? Because if we know like a 90-degree angle here, that would be 180, and then that's be halfway between 90 and 180, so you can see it's 135 degrees. So that's part 1. Part 2 is to find the reference angle, and remember that the reference angle is going to be the positive acute angle between the terminal side and the x-axis. Well, if I've already traveled 3 pi over 4, and I know halfway around the circle is 4 pi over 4, that means I need to travel pi over 4 to get back to the x-axis. So that is going to be my reference angle. And again, we use denotion as theta prime to represent our reference angle. And then last but not least here is find one positive and one coterminal angle. So again, remember that positive and negative coterminal angles are going to be angles that have the same initial and terminal side. So I'm going to explain this one further, and then for the next rest of them, I'll kind of go through a little bit quicker. So just remember, if we have an angle that starts at the same spot and ends at the same spot, then those two angles are coterminal. So you can see that this angle starts and ends same spot, but it's in the negative direction, right? So how do we basically find that? Well, you can see that this angle and that angle would add up to 360. So if I took if I basically took this angle and subtracted 360 away from it, I would just be left with that coterminal angle, which is the black, which we'll talk about. In addition, I could also go in this positive direction. Let's do gray, I guess, or brown. I could also draw an angle. And instead of stopping here, I could go all the way around one more time, basically adding 2 pi again. So the easiest way to kind of think about coterminal angles, and again, this isn't always going to be the case, but the easiest way to think about it is to take your angle, which in this case is theta, equals 3 pi over 4, and then plus or minus 2 pi. Now, we don't really want to add fractions with, with these whole numbers 2 pi. What we want to do is rewrite this in terms of fractions. So 2 pi is equivalent to, well, if pi is 4 pi over 4, then 2 pi would be 8 pi over 4. So I'm going to kind of break this up here, and I'm going to say my two coterminal angles here, I could just do 3 pi over 4 plus 8 pi over 4. And running out of space a little bit, and theta equals 3 pi over 4 minus 8 pi over 4. And therefore, I get 11 pi over 4, which was my brown angle, and I get negative 5 pi over 4, which was my black angle. Okay, so that's kind of an explanation of understanding what we're doing. Now let's just kind of work through the rest of them a little bit quicker, so we're not going to take like 2 hours to do our homework assignment. All right, so negative 5 pi over 6, notice that that is in the negative direction, so we're going to be going down this way. You can see that halfway around the circle here would be 6 pi over 6. I'm just going to keep that positive because we just know we're going in the negative direction. However, I need to only go 5 of these, so what I can do is draw this into thirds. Into 6 parts, 6 equal parts, and then I just need to travel, starting here always, and I need to travel 5 of these. Boom. So there would be my angle in standard form. We want to make sure that we have the direction as well as initial and terminal side. And again, you don't need to draw this, kind of half circle here. I just kind of use that to help me as far as at least instructional purpose. Let's go ahead and find the to write this in radians. So my theta in degree mode is going to be negative 5 pi over 6 times 180 over pi. And I can basically just divide, the pi's divide out, 6 divides into 180 30 times. 30 times negative 5 is going to be a negative 150 degrees. Okay, and therefore that kind of makes sense. We know it's negative, and it's not going to be, it's 30 degrees less than 180, which is our reference angle. So again, remember the reference angle is basically saying how far away is this terminal side to our x-axis. Well, again, that's really, you've traveled 5 pi over 6, you need to go pi over 6 more, right? So theta prime, in this case, is pi over 6. Number 3 is to go ahead and find the coterminal angles. Again, here we can see that the since this is within 1 revolution, the easiest thing to do is just to add and subtract 2 pi. So therefore, I'm just going to say my coterminal for number 3, I'm just going to take negative 5 pi over 6, and I am just going to add and subtract. Now, again, instead of writing this as 2 pi, I'm going to write this as 12 pi over 6. And then I'm just going to use set notation here to group these together. So negative 5 plus 12 would be a 7 pi over 6. And negative 5 minus 12 would be a negative 19 pi over 6. Okay, so those are going to be my coterminal angles. And again, you have 1 positive, 1 negative, which I'm looking for. All right, let's work on the next one here is pi over 3. So if I want to go ahead and sketch this, angle here, I'll just use this as my initial side. And again, we could use this half circle, and now we want to break this up into thirds. So Sometimes the x-axis or the y-axis kind of makes that confusing, but you can see here this circle is broken up thirds, like 1/3, 2/3, 3/3. Well, we only need to travel 1/3, so you can see that my angle is going to be start here and rotate there. All right. If I was going to go ahead and convert this now to degrees, I would just take my pi over 3 and times it by 180 over pi, 180 degrees over pi. And pi's divide out, 3 divides into 180, let's say 60 degrees. To find my coterminal angle, since we know that this is in the first quadrant, we could say that the angle is the same as the coterminal angle. And that's true for any angle that's in the first quadrant, as long as it's, well, it has to be acute to be in the first quadrant. But that's something that's true because the distance from the terminal side to the x-axis is exactly the angle. So when you have an angle in the first quadrant and you need to find the reference angle, it's exactly the same. You don't really need to find it because it's the same angle. But anyways, we'll just do that as pi over 3. And again, since this is 1 revolution, let's see. Let's write that in there. So again, that's our theta prime. And for number 3 here, for number 3, since this is within 1 revolution, I'm just going to add and subtract 2 pi. So therefore, I'll just now, but again, rather than using like 12 pi over 6 or 8 pi over 4, I'm going to want to do 2 pi in terms of thirds, which would be 6 pi over 3, right? Because 6 pi over 3 simplifies to 2 pi. So what I'll do here is, let's take my angle, pi over 3 plus or minus 6 pi over 3. And when doing that, I get the set 7 pi over 3 and negative 5 pi over 3. Okay. All right, let's go into D. Now we're dealing with an angle where I think it's really kind of helpful to understand this kind of circle idea. So let's go ahead and draw this in purple. All right, so now we're dealing with thirds, right? And I did that previously over here. So if we were going to draw this in thirds, we know that halfway around a circle is 3 pi over 3. And if I continue that circle, we would have 2 pi, which we've already practiced, which would take us to 6 pi over 3. So what you notice here is that, what I notice here is that I've already gone over a revolution, right? I've already gone 6 pi. So what else do how much farther do I need to go to get us to 10 pi? So the way I like to do this is when we have an angle that's greater than a revolution, right? All of these angles were less than a revolution. But when you have something that's greater than a revolution, make sure you understand it, what we call in terms with period as an 8, as they say. So what I can do is I can rewrite this as 6 pi over 3 plus 4 pi over 3. Because really, the 6 pi over 3 is just going around the circle, right? Now I need to go 4 pi over 3 extra. So we really can just like disregard the 6 pi over 3 as far as understanding where this angle lies. And so to understand where this angle lies, what I have done is I need to break this up into thirds, and I'm going to break the bottom up into thirds. Okay? So I travel. This takes me to 6 pi over 3, which is just a revolution. And then basically we need to go 4 pi over 3 more. So 1, 2, 3, 4. So it's going to take us all the way down there. So that's what our angle is going to look like. Don't really need anything else in there. We just really need the blue without those kind of lines there. But that's going to be what our angle is in standard form. Now, this is actually helpful to understand it in this way is very helpful too when we're looking into converting this into degrees, because I already know 6 pi over 3, that's equal to 360, right? So I already know that that's 360 degrees. So then all I need to do here is just go ahead and convert 4 pi over 3, because nobody really wants to multiply like 10 times 180 and then divide it by 3, right? That's just not going to be that much fun. I mean, obviously you could do it, and this problem doesn't seem that difficult, but sometimes you might have something where it's a little bit difficult. So I'd like to take out the periods, rewrite them as how many revolutions they are in degrees, because that's easy, fairly. And now let's just convert 4 pi over 3. So 4 pi over 3, so let's do the work over here. So 4 pi over 3 times 180 over pi. 3 goes into 180, which would be 60 degrees. 60 times 4 is going to be, that's going to equal 240 degrees. right? Pi's a divide out. That goes in there 60, so 204 degrees. So really, I hate when that happens. So now when I'm adding this, I'm really just adding 360 plus 204 degrees. So question number 1 is going to be theta is equal to 600 degrees. Number 2, find the reference angle. Again, it doesn't matter how many times we're going around the circle. The reference angle is just asking us how far is this angle away from the x-axis. And you can see I just traveled an extra pi over 3. So theta prime, in this case, is again just pi over 3. And then let's go ahead and work on number 3. Now, number 3 is interesting because we're at an angle that is greater than a revolution. And if we add 2 pi over this, we're just going to keep on getting larger and larger numbers, right? So rather than adding and subtracting, if we just subtract 2 pi from there, right? If you took 10 pi over 6 and subtracted 6 pi over 3, you're just going to get 4 pi over 3. So there's already your one positive coterminal angle. And then what you can do is, so what I like to do is just take, 10 pi over 3, subtract 2 pi. So I'm not going to want to add, because when I subtract 2 pi, I get 4 pi over 3. And then just to find another coterminal angle, I'm just going to subtract 4 pi over 3 minus 6 pi over 3. So I'm just going to take that last angle, and then I'll get negative 2 pi over 3. So those are going to be my 2 coterminal angles, one positive and one negative. Could you add? Sure. Could you keep on subtracting? Sure. But if you're just asking for like the smallest, one positive, one negative coterminal angles, then that would be a good method for you. All right, for these last 2, we're just going to kind of hopefully work through these a little bit quicker. So here we can have negative, and you can see it's negative pi halves. So if we know that from here to here is pi in the negative direction, then half of that, right? Because this one sometimes gets students. Remember, this is the same thing as negative 1/2 pi, right? Negative tells us the direction, and then the 1/2 is like 1/2 of pi. So that angle would be from right there. So that is basically our angle in standard form. I already know that that is a 90-degree angle, so I'm not going to show any work for that. I can just say 1 theta in degrees is 90 degrees. For number 2, the coterminal angle does not exist because coterminal angles has to be acute, and 90 degrees is not acute. So I'll just say none. And then for number 3, again, this is within a revolution, so I'm going to want to add and subtract 2 pi. So for my, basically what I'll do is I'll just take negative pi halves, and then 2 pi in regards to halves would be 4 pi over 2. So I'm just going to add and subtract 4 pi over 2. And I'm just going to kind of write my set notation below. So if I added, that would give me 3 pi over 2. And if I subtracted, that would give me a negative 5 pi over 2. And if you were to graph those 2 angles, you would see they would have the same initial and terminal side. For the next one, theta equals negative 6 pi. Well, again, we're going in the negative direction. Here is 2 pi. Here's 3 pi, 4 pi, 5 pi, 6 pi. So it's a lot of extra revolutions, right? But just count. We know every single revolution here, right, is just going to be a period it's just going to be a period as an aid. So to convert that, we basically got to count up. If we want to convert that in degrees, let's just count up how many times that we went around the circle, like in degrees. So going around the circle once is 360. Going around it again is going to be 720. Going around 3 times is going to be 1080. So we could say 1080 degrees. For number 2, we're looking for the reference angle, and again, you can see that we're on the x-axis. When you have an angle on the x-axis, that's going to be an angle of 0. So again, there's not going to be a coterminal angle. So we'll just say, a reference angle. So theta prime in this case there is no reference angle. And then for number 3, if I wanted to find a angle, then I just got to add and subtract 2 pi, right? But since this is greater than the revolution, I just want to continue either adding or subtracting until I get 2 of the both. Well, since this is already negative, see, in this case this was positive, so I subtracted twice. Since this is negative, I'm just going to want to keep on adding. And so if I take negative 6 or negative 6 pi and add 2 pi, that gives me negative 4 pi. And then what I can do is take negative 4 pi and then add 2 pi again, right? And that's going to give me a negative 2 pi. And then I can take negative 2 pi and add 2 pi, and that gives me 0. And then if I took 0 and added 2 pi, I would get 2 pi. So now, since 0 is not positive or negative, I have two coterminal angles. That's one's negative and one's positive. All right, so that was it with radians. So radians is kind of tricky, so I did kind of spend a little bit more time than I was really kind of expecting to, make sure that you guys really kind of understood where I got to them. In future videos, you guys will, on my homework, you'll see me just kind of like start sketching them and start doing some things on my head. So if this was a little slow, like too slow for you, I apologize. I do pick it up later. I just want to make sure that everybody's on the same page before we really start getting to stuff, because we're going to start doing these problems very quickly. Like I've already taken 20 minutes doing this, whereas we could probably do this in like 2 minutes, right? So, but as far as the learning process, that's where we want to begin, and then we'll pick up speed as we get more and more comfortable with it. Now with angles, that's something that hopefully people are a little bit more familiar with. And again, we're just going to do a rough sketch. So this is positive. I know from here to here these are all 90 degrees, right? So I just like to use my understanding of 90 degrees to kind of represent, I was going to try to be like artistic or something, but let's just draw. These are all 90 degrees. So I just like to use my understanding of 90 degrees to know where the angle should be. So 240, well, that's 90, 180, 270. So 240 is going to be somewhere around there. Okay, there you go, and in that direction. And again, I'm not very picky on my students as long as it's pretty obvious. I mean, as long as it's close and within reason, then they'll get credit for the sketch. Now, the one big change here is when we're converting degrees to radians, we don't want to use the same conversion ratio, because when we use this conversion ratio, the 180 over pi, we are trying to have the pi's divided out. Well, we don't have any pi's to divide out here, but we have a degree, the units of degrees that we want to divide out. So now our conversion ratio is going to be pi over 180. Okay, so by doing that, our degree symbols is going to divide out, and now we simply just need to reduce the fraction 240 over 180. So the easiest thing to do is divide out the zeros as well as the degrees. And then I just have 24 over 18. So I want to say, what is the largest number that divides evenly into both of those? And I am thinking 6. So therefore, that would be 4/3. So for question number 1, I am getting theta is equal to 4 pi over 3. As far as 2 goes, basically, again, I'm thinking like, how far is this away? So if I'm at 240, and I know at halfway around the x-axis is like the degree of 180, to find my reference angle, I just need to basically say, like, how far is it? So from theta, so theta prime is basically 240 degrees minus 180, right? That's going to tell me this distance right here, which is the reference angle. And therefore, you guys can see that that is going to be 60 degrees. And then last but not least is going to be finding my coterminal angles, which with degrees is pretty simple because 2 pi in degree form is 360. So since this is within revolution, I'm just going to take my 240 degrees and then add and subtract 360. Okay, so therefore if I add them, you can see I get 600 degrees. And then if I subtract, I am going to have a negative 120 degrees. All right. All right, let's get into negative 540. So negative 540 is obviously going to be larger than a revolution, and it's going to be negative. So let's go all the way around. That's negative 360. And then if I go another 90, that's going to be negative 450. And obviously if I go another 90, 450, that's going to be negative 540. Right? I believe. Hopefully. Yeah, 360 to 80. So you can see there I'm landing here on my x-axis. So again, basically, now, again, I could kind of think about this rather than trying to convert this using the conversion ratio, which we could, where there's nothing wrong with that. But I think it's easier. Like if I know this angle, I know that all the way around here is 2 pi, and then all I literally did is just add an extra pi. So my angle in degree form, theta, is just equal to a negative 3 pi. Now, if you want to use your conversion ratio, fine, do the conversion ratio. But guess what you'll get? Negative 54 divided by 18, which guess what is? -3. So therefore there you can kind of work, but I'll keep it simple. -2, since it is on the x-axis, there is not a reference angle. And then number 3, since this is greater than a revolution, I am just going to keep on adding 360. So basically, if you think about this, if I just add 360, right, I just add 360 back, that's going to take me to -180. So I can say that the, coterminal angle, one coterminal angle would be, well, that'd be a negative, right, because we're going in this direction. So if I added 360, that's going backwards. That would take me there. So that's going to be a -180 degrees. And if I added 360 again from there, then I would basically have another positive angle, which would be 180 degrees. I don't know why I wrote the theta with the degrees. Okay, almost there. All right, let's go and do J. I don't know why I chose I to do on my homework. I apologize for my students, but it is something we should know how to do. It's just not something that we're going to have on the quiz. But let's do J real quick. 135 degrees. So I know that here's 90. From here is 180. So it's going to be halfway between 180 and there. So we can say there is our angle. If I was going to convert this into degrees, so I just take 135 degrees and times it by pi over 180 degrees. Then I need to figure out what the heck divides into 45 and 180. Fortunately, I realized that I've been working with these numbers a lot. I know that 45 divides into 135, right? 45 plus 45 is 90, plus another 45 would be 135. And then also 45 divides into 180. That's going to be 4 times. So it divides into 135 3 times. So therefore, I get this angle, which is 3 pi over 4. Which again, you could also kind of think about that in terms of your radians. Now, our reference angle, again, is looking for the distance here to here. I like using reference angle in terms of pi, but again, if we wanted to find this distance, we know that halfway around a circle is 180, and we've already traveled 135. So our reference angle is 180 degrees minus 135, which is going to equal 45 degrees. Or pi over 4 in radians, just if you're kind of keeping score. And then we have number 3. Number 3, coterminal angles, add and subtract. So we're just going to add and subtract 3 pi. I'm going to keep this one kind of simple. So 135 degrees, plus or minus 360 degrees. So if I was just going to add them, I'll use set notation here. That would be 495. And then dreaded subtraction is going to be -225. 200, let me see, well, let's just do 180. Yeah, -225. Boom. Okay. Now, the problem with this one is, it's not hard to sketch I. Like, that's going to be greater than 180. I'm sorry, greater than 90, but less than 180. So it's going to be somewhere around there. All right. So it's not difficult to sketch the angle. The difficult thing is going to be converting it. And, well, actually, it's not actually difficult to convert because if I wanted to convert this, and if we didn't have a calculator, there's really nothing we can do, right? It's going to be 101 degrees, 111, times pi over 180. Well, the only thing that can really simplify out, as I'm concerned here, is going to be the degree symbol. So I'm just going to be left with this fraction, 111 pi over 180, because I'm not aware of anything that divides into 111 as well as 180. So if I'm wrong, please let me know. But as far as my initially looking at, I don't see any anything that's going to do that. So So yeah, we'll just leave it like that. Obviously, if you had a calculator, you might have a decimal that you'd have to go ahead and round. For number 2 is, again, we're looking for the reference angle, which is basically going to be this distance. So theta, since it's in the second quadrant, we're going to do kind of the same thing. I'm just going to take 180 degrees and minus 111 degrees. And you can see that that is going to be equal to 69 degrees. I don't know why I put a 0. And then, ladies and gentlemen, if I need to find the coterminal angles, I am just going to take 111 degrees and add and subtract 360. So I can say theta is going to equal 471 degrees, and then if I was to subtract, basically I would have 180 plus 69, which would be 249. Then I could say theta equals negative 200, theta is equal to negative 249 degrees. Okay, boom, 30 minutes. Took a little long, but I went ahead and hopefully you guys got some value out of the explanations. I'm just going to take a quick little break. For you guys, if anybody wants to go ahead and work on the multiple choice, I got 4 questions here. Feel free to do that, and then I'll just kind of check in on the chat, see who you guys have joined in. Hey, Exorbitant Mango, 21 Darkster, so it would be 6 over 16 plus y equals 1. I guess you have a question. I'll go and look into that. Oh, Abraham is helping you out. Awesome. I love you guys helping each other out. That is really, really sweet. To see you guys. Well, I'm in 9th grade, probably going to do this in year 10. This looks complicated. Yeah, Gunnar, this is for trigonometry or in a pre-calculus class, so it just really kind of depends on what path you're on. It is difficult for many students to kind of get used to it. I do find that some students though also can't stand algebra and everything that we do in our algebra class, but then they get to trig and they're like, I love this stuff. It makes sense. I get it. It's kind of like that debate of the geometry student versus the algebra student. Some people love geometry. Some people hate geometry. Some people love algebra. Some people hate algebra. So I think it just kind of works, of how you really understand a lot of the stuff. And Doctor, you had a lot of questions. I guess it's going to be difficult to kind of see if you got yours question answered. So let me know, Tony Darkster, if you need any more help or if you guys were able to kind of get that figured out. Dustin says, skip geometry after Algebra 1 and went right into Algebra 2. Hey, and that's possible. There's actually a lot of thought that I've been doing as far as our math curriculum and the way it's designed to really prepare you guys for not only college but really just the real world and and how we have everything structured. Obviously, I now kind of teach the upper level math classes at my school, so I'm not as in it as I used to be, but I've taught Algebra 1, Algebra 2, Geometry, and all those classes, and I think we do a lot of disservice, and I remember teaching them, and it was very difficult to teach a lot of those classes a lot of times because there would be a lot of students that, were teaching them this stuff, and I'm like, there's really no need for me to, be teaching you this. There's so many other concepts within this curriculum that I would love to teach you that I think you would get more of a benefit on and actually be able to apply, and you'd actually enjoy it. But rather, we're still just kind of teaching stuff because we still test it, and that's how we are kind of graded, by the state, by the community, and so on and so on. So, but that's just kind of it. So, all right, guys. Well, I see... Ryan says it's easy. This is clutch, AJ. Awesome, AJ. I'm happy you are in here. So, Destiny and Narissa, nothing teaches every day. I watch these YouTube videos. I say you're my teacher. And Destiny, I take you as my student. So I like to post, every week, and that's why I will continue making live streams for the rest of this year. So if you guys, can usually expect me to be going live at least once or twice a week. Mr. King says we're rolling in his math class, but I'm not. My training wheels need more practice. And that's right. It just takes a lot of practice. That is really the key. I mean, obviously, you got to kind of have some basic understanding of what you're doing and the purpose behind it and why you're doing it and, having it make sense. But once you kind of have that grasped, then it's just a lot of practice and repetition. And that's a lot of times, why, I could have done 3 or 4 examples here, but I chose to do more examples in this lesson because I know it's something that students, we need to be able to do this very quickly. As I mentioned, I spent, 30 minutes going over this. This should take us 2 minutes to do. And so, but it's not going to take us 2 minutes the first time we're learning it. It's going to be slow, right? And it's going to take some practice. But hopefully my students are working on this and we'll be able to get this down to 2 minutes. All right, so let's go ahead and finish up this warm-up, and then if you guys have any other questions that I didn't get to see, please repost them, and I'll go back and take a look at them and wrap this up. But I'd like to try to finish this hopefully in the next 10 minutes because it is a Saturday, and Michigan State is playing Ohio State, so I want to make sure I catch that as well. So since I'm from Michigan, I like to watch those games. So, all right, convert from radians to degrees. So obviously we just need to make sure we're using our conversion ratio. 3 pi over 2 times 180 over pi. We know that the pi's divide out. 2 goes into 180 90 times. 3 times 90 would give me 270. Convert from degrees to radians. So I'm going to use the other conversion ratio here. I would have 190 degrees times pi over 180. I can divide out the degrees, divide out the zeros, and I'll just be left with 19 pi over 18. That'd be A. Find the measure of two angles, one positive, one negative, that are coterminal with the given angle. So again, we want to use our conversion ratio of what is 2 pi in regards to 5. Well, that's going to be 10 pi over 5. So if I take 4 pi, if I add 10 pi, that's going to give me 10 pi over 4, that's going to give me 14 pi over 5. So everything that has a 14 pi over 5 is going to be good in my book. So that one works. Now let's go ahead and subtract 2 pi. So 4 pi over 5 minus 10 pi over 5. And that would equal a negative 6 pi over 5. And that one works. So, I mean, obviously there's no other angles between 4 pi and 10 pi that would be coterminal. So that one doesn't work, that one doesn't work, and that one doesn't work. So I guess I could have, identified B as my answer earlier, but I went with that one to make sense. Number 4 is find the reference angle for the angle given. Nice. This one's a larger than 360. So what I'm going to do is I'm going to rewrite this in terms with period as an aid. So basically I'm going to take 436 degrees and I'm going to say, well, that's really one revolution plus like what, right? What am I adding to that? So it's really going to be adding, let's see, 76 degrees. So plus 76 degrees. So basically what happened is the graph went all the way around 360 degrees, and then I added 76 degrees. Well, that's in the first quadrant. So therefore I know that whatever I traveled here is still going to be 76 degrees. So that's going to be my reference angle. So A would be my answer. And there you go. And then if you're kind of interested, I also just kind of did some other angles that you could kind of work on if you wanted some extra help. So let's see here. Are you guys rolling in math? Federal Bureau, the FBI. Hey, how are you? Liar, how are you doing? I got 91 math curriculum. Hopefully I can stay there. LOL, I got these videos often. Well, yes, FBI, just keep on going, man. That's awesome. Congratulations on the 91. That is, true testament to your work, and just keep on working at it. Keep up the work, says Wild Style Zach. Yes, I will, man. It is a lot of work. It is a lot of time outside of class, but I enjoy it. It actually is giving me some more stress this year than I've done in previous years, because I'm trying to stay on top of this for my students as well as for you guys. And, it's taking up time where I used to respond to a lot of YouTube comments, and I just aren't able to do that really anymore. I respond here and there when I just really have that extra time, but I just don't have the, free time, because a lot of times I'm doing these live streams. I mean, I'm twice a week, and then obviously working on creating all of these materials, for my students. And again, if you guys are interested in any of those, I am posting all this homework, all the quizzes, all my tests are posted, as well as cheat sheets are posted on my channel membership, which if you guys haven't tried this out, I mean, feel free. I'd love to kind of get some feedback. I already have some people that are taking advantage of the membership and are kind of utilizing those resources. They are primarily for pre-calculus. I mean, obviously a lot of the topics are going to work into Algebra 2 as well as into calculus. But, it's basically my curriculum that I've created for pre-calculus that I am giving away. Not really giving away. Obviously, you pay to be a member. But, if that's something that you like that, then feel free to go ahead and check it out, see if it works for you. If not, I am going to continue posting free videos every single day, as well as join you guys on the live stream. So I am going to get out. How often do I go live? I usually try to go, it really depends on when the homework is, Destiny. I wish I could probably do, it would be best if I could tell you guys when I'm going live and go at that date. But, since I have 2 young girls at home, and school, I have parent conferences, and everything always gets thrown in a mix, I just can't commit to like Tuesday and Thursdays at 4 o'clock. So I'm just kind of at a hodgepodge, but you can probably expect, the easiest way to make sure I'm going live is just to, make sure you're subscribed to my channel and make sure you kind of get that notification signed on. So therefore, every single time I do go live, it's going to ping, send you an email, whatever else, let you know. And then maybe if you're like not doing anything, you want to check some math, then you can obviously go ahead and join me. So I'm going to peace out. Hope you guys have a great rest of your day, and I will be going live next week as well. So hopefully you guys can join. All right. Peace out.